Now sometimes we need to Washer method, the y-axis. So if I look at the solid form revolving the graphs of y equals x squared, 1, which is this curve right here, y equals 0, x equals 0, and x equals 1, so it's a shaded area, about the y-axis. The first thing I want you to notice is we are going to have two different integrals, because when I draw my representative rectangle here, the top of this function is x equals 1, and the bottom of this function is x equals 0, while the top of this function is x equals 1, but the bottom of this function is x equals the square root of y minus 1. And I do want the positive. So this is what my solid looks like. But in this problem, I'm actually going to do two different integrals. Now, the process is the same. I've drawn my diagram. I put in my representative rectangles. I know my limits of integration are going to be from y goes from 0 to 1, because that's where this function starts. And then I'm going to need to go from 1 to 2. Now let me look at my first volume. All right, delta V equals pi, oops, forgot my V there, pi r squared delta y. So I'm just going to call this delta V1 because this is my first one. So this is the first area down here. So this first volume, the first volume is going to be the integral from 0 to 1 of pi. Oh, I'm right what R1y is, did I? You need to go on and do that. R1y is the height of this rectangle, and the height of this rectangle is right minus left, so it's 1 minus 0, 1. So this becomes 1 squared dy. So this just becomes pi x evaluated at 0, 1. So it's pi times 1 minus 0, or just pi. So this volume right here is pi. Now, the second part, add on, and you'll get to where you do this in one step. The V2 is pi r2 of y squared times delta y. Now, what is r2y? Always right minus left. So this is going to be 1 minus the square root of y minus 1.